So, hi everyone, my name is Yosun Chang. I'm going to be giving a talk that's called Designing Native Apps for a Group Class with Live Demos. And this is actually a live talk I'm giving right now. Because, alright, hello, hi, hello, can't hear people. But yeah, I know this noise cancellation is so hard to hear unless people are speaking on a mic or something. Right, so, okay, so, quick audio check. People can hear me, right?
Yeah. Can you hear people?
I can't hear people, so I guess there's questions, so have them go to the microphone or come on the stage and talk to the computer mic. Okay, great, so audio good? Okay, let's start. So this is, well, some of the APKs will eventually be posted to hackingglass.com, which is a glass hack sort of thing. So basically, this is designing native apps for Google Glass. Okay, so we'll start with a broad overview of what you get from a hardware class. This is from the dissection sponsored by SparkFun that Wig did. And so in this case, I just highlighted the sensors of interest that if you want to build some interesting sensor software, you might consider looking into. So this is a very high-level overview of Glass dissected, and we'll begin with the Synaptics Touchpad, which is a long strip on the edge of Glass. Let's see, I guess I'll demo. This is the touchpad. So unlike your classic touchscreen, it's long, and it's a touchpad instead of a touchscreen, so it's not responsive. We'll go over that later. But the dimensions is actually 1366 by 187, which again, it's very different than your traditional ratio. And there's also other sensors. The VenSense 9 degree of freedom sensor with the gyroscope, accelerometer, this each degrees of freedom. And we also have a display, the 640 by 360 screen that's projected from the optics in front of you. So what does that mean? So actually, you see this glow right here. This glow right here is the screen being projected in front of you. The experience as a user is, I guess, quite different. I think as a user, you probably aren't as bored-like, I guess, instead of as a third person, I guess. It's kind of bored-like to see it glowing at you like this. Right, this is odd screen visualization. Okay, and right, there's also noise cancellation microphone, which makes it great for stuff like Hangouts and such, assuming that you have sufficient bandwidth. And there's a light sensor, which eventually show up other cool hacks with that, including a baronet and a light trombone, bass trombone, stuff like that. And then there's a camera, the usual crappy camera that you find on a lot of lower end phones, but this is, I guess, developer edition. Eventually, there might be higher-end cameras on the final release. And there's also the speakers. These are bone conduction speakers. The big issue is that it's not going to be 3D sound. So if you have a game that depends on 3D sound, like for example, like a box blows up in the like fourth quadrant or something, and that's really crucial, that's probably going to be an issue in design. Okay, so since this is a sensors talk, so let's go over how you pull sensors. This is pretty basic stuff, but you can check for sensors using Package Manager or use the location sensor APIs. And this is basically just all in the manual. Great, so we're probably interested in what sensors Glass has, at least the publicly known ones. So this is a screenshot of the sensors and some sample values. So there's the usual 9 DOF sensors, the accelerometer, the magnetic field orientation gyroscope, so that's from the VenSense, and there's also a light sensor, and also more values from the VenSense stuff. These are some sample values. Here's the max range, and the light sensor is interesting. It goes anywhere from 0 to 64,000, and we're I guess you're probably wondering what the metric is or the scale. When it's a bright sunny day, it's about like 500 or like, it's never been more than 1,000. So I'm not sure how bright 64,000 brightness requirement for that is. Okay, and interestingly, there's no pressure sensor on glass, so you don't have altitude. You can get GPS, but see, I guess I don't have it listed here. So these are the glass sensors. Great, basic stuff. And if you've never pulled sensors before, here is the general recipe. Import these libraries, implement sensor event listener, create the sensor, manage your instance, and on create, and then register sensors, and on resume, and then basically in the on sensor change method, you can do whatever you want the sensor to do. For example, you know, your sensor should like rotate the camera, or things like that. Great. Simple, right? Can't hear the audience, so I'll assume this is super simple. Okay, so sensor fusion. So you actually get reference data. However, this kind of requires further filtering if you want to do more interesting stuff that requires precision, such as multi-user games where the orientation of people's heads is pretty important. So you can do some Kelvin filtering on that, and also you can, you know, combine many more sensors here, not just the events and stuff, such as the light sensor with motion, camera with swipe. I guess that's pretty trivial. But yeah, sensor apps combine the sensors together, make cooler stuff. You know, things that are more interesting than HTML5, where you can only access the accelerometer, so you have a lot of sensors as mentioned. Okay, so input output. So the input sensors for glass. So there is the touchpad, as I mentioned. It's not a touch screen, and there's the camera, pretty low resolution, light sensor, and then the InventSense 90OS sensors, and then compass, GPS, microphone. Simple. Design sensor constraints. Okay, this is where I mentioned earlier that unlike traditional touchscreen design, you are not using a one-to-one ratio with touch to screen. And this might be a bit counterintuitive, especially if you're assuming that the user can finger touch on the actual button. But there are different constraints to work with for that. So this should be rounded, but you can see that the ratio is very odd. Display the touch ratio. And that's because, as mentioned earlier, the screen is 640 by 360, and zoom out. The touchpad is super long. The screen is a regular wide screen. So 640 by 360 and 1366 by 187. So trying to make things map one-to-one is generally not going to be the easiest, unless you mix and match sensor fusion stuff, as I'll show later on. And also you should do some sensor brother filtering, more sensor fusion. The compass alone is off by like 15 degrees, which if you take it into a wild, you're going to fall off a cliff or something dangerous. Very bad compass. And then bone conduction speakers, and so the user must cover your noisy environments, noise pollution. And that also, because the bone conduction speakers are only on right here, you basically don't have 3D sound. It's just you kind of hear buzzing, vibrating on your head. And then it has a tiny battery, 570 milliamps. Okay, and output modality is, you have a display. It's seen floating roughly in front of you, a computer projector and audio optic, and there is bone conduction, as mentioned, and I guess the most interesting part is that the real world is part of your output modality. So try to make semi-transparent or reality-connected apps, I guess. To make an APK for glass, or i.e. a native for glass, you basically develop for Android ice cream sandwich, but keep in mind it's a different form factor. Touchpad doesn't have one-to-one screen, which basically means that you're going to have to redesign the input motif for your button stuff. and bone production, you don't have 3D sound. And it's kind of a limited device, but it's kind of a beta edition, so consumer release might have better specs on hardware and low battery life. Okay, so overview. Okay, the fun part, live demos. So I'll start by showing the Gyroscope platform. So Gyroscope is basically a natural UI platform for Google Glass. Combines a lot of cool stuff, but I guess I'll show out something that I think is a pretty cool way to demo Glass apps. So a big problem with demoing any Android app is that there is no way without extreme frame loss to demonstrate what's on your Android or say your Glass screen live on a projector. Because Glass actually doesn't support MHL, it only has a micro USB that even connected to AS gives like what, 5 frames per second, pretty bad. So this is Gyroscope. It used to be called Glass Shootout. So this is kind of what the experience on Glass is like for the app. As you're rotating your head around, your view is transforming, and what you're seeing is kind of out of field of view in the top right-hand corner of your eye. But you can also adjust Glass to shift your view and stuff. So basically, Gyroscope lets you tap to shoot or tap to fire. So I'm gonna aim my head this way and tap. Did you guys see how it's tap to fire?
No,
And
there's no video. Something's going on.
did it just stop?
Yeah, it's stuck on sensor fusion. The slide.
When did it stop on sensor fusion?
About 10 minutes ago. Do you want to try to restart the screen share?
Yeah, you should have stopped me then, I think, because I think I went through a lot more after sensor fusion.
Send you a message. I guess you didn't get it.
Stop sharing, start sharing, share screen.
Oh, wow, the resolution's on.
Okay, I just restarted the share. Is it? Hello?
Yeah, it's on the right.
Is it? Okay, does it say IO in big letters?
No. Yeah.
IO?
Okay.
Yep. So the screen is back again, right?
The resolution got messed up though.
Is it mirroring the resolution or?
No.
How bad is the resolution?
It's close. Well, everybody says it's fine.
Okay, people can read or something, right? I guess.
I guess so.
This is legible, sensor design constraints. Okay. Okay, so sensor design constraints. Okay, so I guess for future note, if the screen stops, just like notify me immediately, because otherwise I'll kind of go on assuming you're seeing what I'm seeing, which is awkward. So design constraints. So as I mentioned, the ratio is not 1:1. It's really the fraction looks kind of weird. The compass is off, and you should compensate for that by using sensor fusion, motion fusion, Kelvin filtering, things like that. And then there's bone connection speakers. You should basically be aware that 3D sound is, well, I'm repeating what I said, so this is interesting. What did I show earlier? Yeah, FaceTime. So I was demonstrating that, again, the audio comes from this thing right here. It vibrates your head. So it's basically not going to be 3D. So depending on what you design, sound. Because sound is another way of input, so it might be a big thing depending on how your design is focused. But be aware that it's not currently 3D. And output modality 640 by 360, and this is same projected roughly 1 feet in front of you. Again, this is the idea of this light right here is actually projecting from onto the optic, and it looks like it's floating in front of you. And bone protection. And I already mentioned that. And then I guess the most interesting part about the aqua modality of glass is that it happens in the real world. And great, so basically making an APK or i.e. a native app, well, depends on how native you go, but is basically developing for Android ice cream sandwich, but basically for a different form factor. And as mentioned, the touchpad is a one-to-one, which means that don't rely on buttons that require exact fingers pressing on it or something. But there's other ways to get by that using other sensors, such as I'll demonstrate soon in the Starfire Platform. And also right now the device is pretty limited actually. So yeah, and small battery. So right now I'll go directly to live demos. Starfire Platform. Okay, so Starfire is basically a naturally derived paradigm for glass or platform. Use a lot of cool stuff, primarily sensor fusion. The AR stuff is kind of, I'll show a demo of that, but it's not publicly on the platform yet. So the idea is that you aim, tap, and fire, which can actually be generalized into a lot more than just a game. So I'll start with the game demo, which is a classic one. So just to make sure, can you guys hear me still? Can you see the screen right now? Yes? Yes. Oh, great. So I have a head rotating around, and this is kind of like a vicarious glass experience. So this is what you would see on the top right-hand corner if you were wearing glass. So it's found a bunch of Bondi boxes apparently, but this is the most basic demo. So I'm going to aim for one of the boxes, and I'm going to tap. So you notice how my finger, or the virtual finger of this head, tap the sidebar, and that instigates the shooting action. So here we go. Tap. And aim. Make the screen a little bigger. Okay, so this is Starfire. So obviously the wireframes can be replaced by meshes. So in this case, I replaced it with goats. Yes. We'll teleport this goat right here. There. And got teleported somewhere around me, maybe behind me. I'm going to aim right here and teleport this goat. And teleport. Okay, so yeah, the idea is tap to instigate an action. I'll switch to laser now. And gotta be precise. It's a great way to practice like head orientation, rotation, or whatever. Head fitness. Okay, so yeah. And if you guys want to try this out, this is running on the glass that you should see on stage that Fern is wearing. So yeah, it's pretty simple. Move your head around, sensor fusion, and tracks the full orientation. So right now, I'm actually showing the demo by just rotating my mouse around, but this also maps to the head being head rotation, changing your camera, and each time you have your crosshair aimed, you tap. Just tap on the side of the glass, the touchpad, and tap shoot. This is a Starfire demo. And there's also extension of that. Okay, so what if you don't want to shoot stuff? So what if you want to play a musical instrument, say, yes, this stuff. So just same thing, move your head around. Okay. Okay, again, this is just a tech demo, but the idea is that gyro beats. Okay, so instead of tapping to fire, this is tap to music, or tap to play some beats. real music, right? Okay. So, gyro piano. So same idea. Instead of tapping to fire or tapping to kill something, tapping to teleport ghosts, you're tapping to play piano keys. I think this is technical, but if you hold down with 2 fingers, you can then play the scales and stuff. And okay, this is the example of using, this is gyro clay. So as I'm tapping, I'm sculpting the clay ball. So I guess using this, you can, use it as any cursor. Use the gyroscope as a cursor, as a mouse point. So the point I'm sculpting is the crosshair, but I'm rotating the sphere, the clay ball, sculpting the clay ball by each time I tap, I'm basically sculpting it. And I can also toggle by using 2 buttons, I guess, well, in this sort of virtual machine-ish demo, I haven't yet included a mesh with 2 fingers, so it's just kind of a generic hand. But right now, I actually 2-finger pressed it. When I 2-finger press it, instead of pulling, it pushes. So, basically. And the nice part about 2-finger tapping is that you can then hold it on your glass without the glass OS exit configuration, putting your app. So glass OS is interesting. So your traditional Android has like a home button and like, settings button. If you press and hold the home button, it gives you, options like show the app and stuff, or switch between apps. So glass has a couple of operating system-wide hand gestures. If you touch hold with your finger, you basically, it will bring you back to the Google home screen. So it's just both annoying and something good to know, I guess. If you design your app to depend on holding 1 finger, it's based on 40 or 3 fingers, which are not interpreted as the operating system-wide override. So yeah, this is gyro play, which uses the idea of tap to fire things. Again?
Yeah.
How long have you been frozen?
Just a few seconds.
Okay, is it back again or frozen still?
It's still frozen.
We'll restart the Skype again.
Yeah, just restart the screen share.
Alright, stop sharing, start sharing. And is it back?
Yes.
Okay, great. So as you can see, rotating my strange sculpture of tap to sculpt. Okay, great. Tap to sculpt. Okay, so you guys have seen that the tap to sculpt in the clay ball, right? Like the clay ball, it looks like it's being sculpted as the head is moving around. Okay, great. So the Starfire Platform. So basically these are demos that I guess try to show that the input is rotating your head, but if I were to just show the screencast of it, it would be, well, you wouldn't quite see the head rotating. So, and this is almost real-time coding from native Python streams. I guess basically just get a socket server running on glass and then send the signal and then broadcast it back to from native clients, and then you can kind of remotely track head position in glass view. Right, so 3 demos. There's actually more interesting demos as well that we might show later, such as Minecraft for glass, and Pebble to load data on some tech benchmarks from the Starfire Platform. I guess you can check out Style Zapper later on. It's on TechCrunch. Right, so, and now something kind of more fun, I guess. Glass trombone actually isn't using the Gyroscope platform, so I'm going to actually just show it directly on glass. So, showing things on glass means that this is what happens when I show something on glass. The frame rate is super bad. I'm using something called Android Screen Monitor, which basically grabs stuff in the screen buffer. So, yeah, it's lagging like a visible 5 seconds or something insane. Okay, so as I'm sliding, I guess I'll go back to the thing.
We need to restart the screen share. We need to restart the screen share.
Okay. Stop sharing screen, share screen. Start. Great. Can you guys hear me? Can you guys see me?
Yes.
Good? Okay, great. So Android Screen Monitor. And just cool. So based on an idea of how I'm moving my head and fingers. Last trombone. Okay. So as I'm sliding my finger, there's the trombone handle is being controlled by where I'm sliding my finger on this side pad, side touchpad, I guess, secondary touchpad rather. And there is a light sensor in the front. When I cover it up and open it, can you guys kind of hear it? Yeah, so right now, there isn't quite a standard for getting audio out from glass to the computer, but basically, every time I open and close this, I'm blowing a note in the trombone. So this is, kind of just, playing with different sensors and mapping it to different musical instrument motifs. So open and close to blow notes, and then slide your finger to, slide it to basically change the handle or the frequency of the trombone. And you can also jump from note to note by, instead of sliding, you just kind of tap. But sliding works pretty well. Interestingly, sliding gets by the operating system-wide exit to go to the Google screen. That if you touch hold, that sort of happens. But if you just kind of slide, it's not as good as touch hold, obviously. So yeah, and that's glass trombone. And then let's see, skip the Bluetooth Wi-Fi. Okay, great. I guess I'll show a demo of the reality 3D stuff. Okay, so meanwhile, actually before I show that, I'll show, where is, I think I missed a slide somewhere. Okay. See, I guess I'll show the thing from earlier, the creating stuff. Creates fire. Okay, so, so yeah, this is a basic example of Minecraft-like thing on glass. So this is a create to fire mode from Gyrofire. So each time, instead of blowing something up, although I have to do that here with this create to fire, I'm just dropping cubes. Now, when I aim one of the cubes, I can blow it up. Great. And just like how the other thing, if I swipe, I can change to different things. In this case, I went to laser mode. So, you guys can't quite hear the audio, but, and goats. Alright, let's put some goats in front. And blow this thing up. Teleport. Alright. Okay, you can't hear the audio right now, but the audio sounds like this. Okay, that's laser mode, you're hearing laser beats. And when I swipe, I'm back in goat mode. And I guess in this case, goats look like really tiny, so I should really resize them. Oh, teleported. And, okay, so, and of course, explosion. Oh. Okay, so that's the audio for that. So, I guess the idea of tap to fire and using the gyroscope as like a new way to, yeah, it's almost like the XY for your mouse, kind of. Right, I'm actually going to switch class. Switch to another pair class. Basically, I have too many apps. I read this based on other pair class, so I'm switching to this one. Oh, hello. Yes, switch to this one. And all right, this is another demo for Marcos AR. Right. And great. So I gotta restart ASM. Great. Okay. So again, the frame rate here is pretty bad. But it shows the idea that, you know, there's barely enough processing power to do some slam on blast. So I'm going to find a particular surface to track. In this case, why not? Design pattern. All right, we have a grand piano on design patterns. And let's turn to a cube, and it's a bench. And, all right, this is the popular terminal. Like dinosaurs. So yeah, I'll put the FaceTime on, or the skeptical one. Will this work? Hello. So, right here, and design patterns. And can even do this works a lot better with audience. You can just ask someone in the audience for like a random piece of paper or something. Let's see. So, actually, we could just do a local demo, like someone has a piece of paper, or say, I don't know, the event voucher or whatever. Actually, anyone with a piece of paper with some design on it, then I could, you know, show the slam no time stuff happening. Actually, I'll just visit a random website. Okay, audience, give me a website.
Website.
Yeah, this is a random website, and then we're gonna slam the website.
Does anybody have a website that they would like to?
Okay. Any websites?
Any websites, anybody?
Google.
Could you use Google?
Any website?
Google Doodle.
Google Doodle, yes. Okay, that's a good idea. Let's see, Google Doodles. I can't spell Google Doodle. Okay, so any particular Google Doodle? Let's see, lots of Google Doodles. Let's try, wow, this is pretty pretty. Okay, let's go for something that has decent contrast and variety, I guess. So this one. All right, we can do this. Yes, can you see me? Oh, here we go. Sorry. Yeah, this is what I'm seeing on my glass. Okay, that's a doodle, and I'm moving my head. Yeah, right. So we're tracking this doodle right here. And oh crap. Okay, I'll send that. Yeah. Okay. So basically, slam working on pretty much anything. Yeah. So it's pretty laggy on ASM. It actually runs at an okay. I mean, it runs at close to 30 FPS on class, which is pretty surprising. ASM again, this is from the screen buffer, so hopefully you understand that what you're seeing here on the edge of screen monitor right here is huge latency. But glass is actually slow. Focus. Okay, see, basically now we're out of the field of view of glass, so defocus. Okay, refocus. Great. So, yep, Google Ditto. Any other requests for those skeptical? Because I guess these are really, I mean, I could have, like, just like all the common Google images, created like markers in advance or something. But that'll be pretty random though. I guess for fun, I'll try another random one. Something that looks interesting. Yeah, just so this is pretty slant. Let's do math. Okay, so in this case, it actually doesn't have enough contrast. Ooh, okay. Good. Well, now it's medium. Let's see. Piano. All right. Here we go. Oh. And we'll switch over to bench. Dinosaur. All right. So I assume the screen hasn't stopped, right? You guys are seeing the time stream. Cool. So yeah, basically I did this on a new surface. This is demarcus AR computer vision. Right. Basically, there's I guess several different ways to do AR. I guess I'll go into a brief discussion on this. So what you just saw is SLAM markless. So looking for POIs. So in this case, looking for the point crossings. So there's other more complex ways of recognition, which is more OCR based. So it could also be that, say, you see an ad and you want to find out more information about it, or QR code, barcode. QR and barcode is pretty simple because you can just use zebra crossing, which is pretty much good enough for most purposes. But in this case, though, it's the step more than just decoding. It's also being able to infer a host tensor so that you can do both the object placements. So just what you saw earlier. And it's actually running pretty hot, actually. Last stop, where it runs my head. Yeah, so those of you hanging out for demos later on, rather, be aware that glass gets hot if it's running for a bit. And actually, you can basically burn glass out. I basically was just running. It's really intense shooting game, a lot more intense than this. And just playing that for about 30, 40 minutes, and glass got really hot, and then it just shut off, and I was actually afraid that the whole thing burned up, but it got charged, and you can actually burn glass out by over blocking foot and stuff. Great. So basically, I have more demos and stuff, but yeah, this is odd because I can't see you guys. I'm not sure what the audience feedback is. If this is clear, if it's not clear, or demo requests or anything. So I guess in the remaining time, which is I think we have 10 minutes or 10, 15 minutes, questions or demo requests. And I guess here's my contact. If you have questions, feel free to email, tweet, my Twitter handle is just Yosun, and email is yosun@soy, which is my first name backwards, and my phone number is also a permutation of my first name, so 4577 Yosun. And I'll post slides eventually, but it's on Twitter. I'm usually posting on Twitter, not really to get blogging, too much cool stuff going on. Okay, so meanwhile, any questions or requests?
So Gyrofire, is it a tool that she wrote, or is it a third-party tool that she uses?
Can you repeat the question? Just make sure.
Yeah. Did you write Gyrofire or find it?
Okay, so Gyrofire is my mini startup that I just hacked together really for like, I mean, I guess from a lot of startups being mini tech, it could be a full startup, but basically it's just gyroscope. I can also add some wrappers for the AR stuff that you just saw, but it's kind of just the extension of something that seems to work pretty well, which is aim, tap, fire, or, and also using your head as a motif to move around. So this is, I guess, eventually publicly available. There's gyrofire.com, but most of these sites are like private beta currently. But I plan to release this thing pretty soon, as well as some way people would download the APK, even though there's no Glass App Store. And fielding regular users and having to tell them how to ADB install, that would be interesting support-wise. But Gyrofire, so I guess to answer the question, Gyrofire is something that I made, but it's kind of more of a hack in the sense that it literally was a startup put together in like a weekend. Well, I mean, I guess it was fleshed out like over a month or so. It's like a summer startup, but yeah. Gyrofire, and so feel free to ask me questions or email me if you want beta access to Gyrofire at Yosun@newsway.